Hello, I'm Dan from Fast Wax, and I'm sure some of you people have seen my ski waxing videos out on the website. And what we're going to do today is something slightly different than ski waxing. What I'm going to look at is the ski waxing irons. They've changed over the years and they don't work as well. Some of the newer irons have a different plate on them. I've thought about doing this video for a couple of years. When I purchased a replacement iron for my original Star iron, I found it didn't work as well. So I measured temperature on it and did several things and looked at it. What I learned is that the plate is different. It no longer has a smooth transition where the wax melts, but it has a sharp ridge on it, and this makes the iron so it doesn't work as well. And the video here is not to pick on any particular brand of iron. The irons are all made in China. They're all about the same. It's just like comparing a Chevrolet to a GMC. The internal components may be different, but the outside frame is exactly the same. So I'm just looking to improve the irons, and I'll show you how to fix them. The key thing here is the fix to make them work right is fairly straightforward. Okay. What I have here in the vise is my original Star iron. And what happened is you can see a bolt inside of it here as I dropped it on the ground. It's gotten some abuse over many years. But the iron still works extremely well. And what I want to really show you here is the difference in the plate. If you focus on that tapered edge of the leading edge of the iron, you can see that it's a nice gradual taper with a very smooth transition to a flat plate. And then it's got a nice rounded edge coming out on the back side of it. These are very key variables in coating. The new irons, they've changed that plate slightly. This is the new Star iron, the one I bought to look at. And what you can see is a key one here is this transition on the plate is very sharp, and then it's got a very sharp ridge across it. Well, waxes don't go from a solid to a liquid in an instant step. They need a transition zone. What this ridge does is it lifts the back of the iron up off of the solid wax and off of the ski, and it reduces the effectiveness of the temperature. The other thing, if you look at the trailing edge of the iron, is it's fairly sharp exit on it. And in order for the wax to coat properly, it needs to have a little bit of a radius on that so it pulls that wax up and lays it down real nice and smooth. When you have a real flat surface like that, it just shears the wax and doesn't really work that well. Here's that same style of iron. This is the iron I bought as a backup to my original iron, and when I got it, it didn't work well. So I looked at that, and you can see what I did here was remove that edge or that sharp lip off of the iron. I also put a little radius on the front of it. So this iron improved tremendously. The difference here is the iron with the ridge on it has to run about 20 degrees Fahrenheit hotter to do the same thing that this iron does. Now this iron performs as well as the original iron. That fix is very simple. I just took a rasp file and filed that edge off, and then took a oscillating sander and smoothed it out, similar to what a guy in a body shop would use. Just to show you that we're not just picking on one ski manufacturer, here's another iron that's designed the same. They all come out of the same factory. They might have different manufacturing specs, but the plates are all the same. And you can see that very sharp edge. And you can also see here a little more clear that very sharp exit edge. So you can take that ridge off of the iron and you can radius that exit edge, and the iron will work much better. Here's another iron, very similar issue with it. It's got a very short transition, and you can see that sharp edge on it. So what's going to happen is this iron's going to ride up a little bit more than the original iron, and it's not going to work as effectively. So this is one where people think it's the temperature that's the problem with the iron, and the temperature really isn't. What it is this design of the bottom plate. Again, you can take and radius that a little bit, and the iron will work much better. Here's another iron. This is an older version of it. You can see that back edge on the iron's got a nice radius to it, and you can see the front end is radius. Now I've touched it up a little bit, but it also had much nicer radius to start with. The original iron, like this one, this notch before that has the half handle, has a much more gradual transition and a much smoother transition, and actually work better. But you can see how they've lost the handle on the design. So what I'm going to do right now is put the one iron in the vise, and I will use my rasp file and my oscillating sander, and I'll take those edges down, and then I'll show you how that looks after it's been done. It isn't that difficult to do. Most anyone that's handy with a file and a oscillating sander can make these changes. Alright, what I've done is put this new star iron in the vise, and then I've taken my rasp file and then my oscillating sander and smoothed the edges out on it. And what I use is a fairly heavy file, or a fairly deep cut file, because you're working in aluminum, and aluminum will load up a fine file. But what I've done is just smoothed that out, then taken an oscillating sander, and I've run this, but it's quite noisy. And I started out with a very coarse piece of sandpaper on it, and then went to a fine, and I just polished that surface off. Now this iron performs as well as the original iron. I was able to drop the temperature that I iron and waxes at by around 20 degrees Fahrenheit, and it works really well. This is a very simple fix that can be done to any of these irons that you have that don't work well. Again, it's not the temperature that's causing the problem, it's the design of the plate.